Hi, welcome back to our channel and back to the tutorial for deep learning. Today we are to see the small interesting project that is how to achieve class image classification using CNN. So this is the one of the demo, answer demo. So before that we have to know some details about the data set that is for achieve this one I'm going to follow the CIFAR dataset CIFAR-10. So generally CIFAR dataset is a dataset available online and free of cost. Its concept generally 60,000 images, where each color image consists of 32 by 32 by sizes, and 10 classes there with const of images per class, where and moreover it contains 50,000 training images and 10,000 test images. So once you go for the CIFAR dataset, there will be categories of images there that is like airplane, automobile, bird, cat, followed by sheep, truck, and so on. So here, so image classification we have to done, and we have to achieve the classification accuracy with the help of CIFAR dataset. And how it means we are going to see the coding now. So this is the coding Google collaboratively followed. So simple and easy. And this is starting one. We are not going to get more than 90%. So for this one, we have to choose the dataset because I am choosing the dataset called CIFAR-10, where randomly collecting some data through online only. First of all, I go to import the packages where TensorFlow is there and Matplotlib is there and NumPy is there. So also TensorFlow is one of the open source library and supports the number of computations, n number of computations for Python also. And NumPy is there, and for this one, we are going to download the data set. So I am going to write the function called x underscore train, comma y underscore train, followed by x underscore test, followed by y underscore test equal to dataset dot CIFAR-10 dot load underscore data. And this is helpful to download the data from the online. After we can write the code called y underscore train dot shape. Then we have to go for array also. Then train the data, again test the data and classes. Just now shown there will be 10 classes there. We are writing the name of the class like airplane, automobile, because once you give the image, the model will get trained and test and show and predict the result. That is, it may be truck means truck, it will say bad means bad or cat means cat, like that. So we are mentioning everything. Then we are writing the plot sample function. We are using the definition function and plt that figure size equal to we are writing 15 comma 2 and so on. After writing the code, you can write the code called plot underscore sample of x underscore comma y underscore train comma 0. So once given that, it will give the show the information that is image. It's not showing accuracy, just not only frog only. And one more, you are writing the code plot underscore sample followed by 1. That means every image having some location, because 0 showing frog and 1 giving means show the track is not clear. Then we are going to train and test and write the form the sequential model, where all of CNN model is there, and CNN model also we are going to follow, because generally CNN consists of 3 layers. One is convolution, one is called pooling, and one more called is the fully connected layers. So we are writing the coding, then follow the prediction model. So choose a data set and load the data set and test, train, test, and predict it. That is the major motto of achieve the image classification. And then we are writing the classification report. Once given that, there will be some matrices there like metrics like precision, recall, F1 score. So for this will automatically generated when you write this coding. And then we are going for the construction of sequential model, CNN model. We are writing the layers dot convolution 2 of filters and followed by max pooling and followed by flatten and dense layer and so on. ELU and softmax. And CNN compile. Here we are going to use the familiar optimizer called Adam, and also calculate the loss with the help of sparse categorical cross interface model method and accuracy metrics also accuracy, like that. Then we are using the fit, that is very important, that is cn dot fit of x train comma y train comma fh value is equal 10, because we are going to collect the data from the CIFAR dataset and test it, whether training testing very important. It may take some time, and after completing we are going for the evaluate, where you evaluate writing the coordinates called x test comma y test, and then predictions we are writing cn dot predict of x underscore test, then writing the coding. And classes also like that we are continuing, and again we are giving the sample like plot underscore sample of x underscore test comma y underscore test comma 3. So approximately we are getting the 70 to 80% accuracy only. Later we go for some other elaborate class image classification with some other method also. And the class is there. At last it will predict whether it's a ship means ship or cat means cat. Here showing the aeroplane. So like that we can achieve the image classification with the help of CNN. I hope that you understand the video. Thank you for watching the video. Thank you.